Great. Conscious of time, why don't we just jump right in? I'm going to go to the last set of questions specific to you, and I'd like to ask the first about your work today and the areas that you're focused on and the accelerator that you've created at Samsung.
Yeah, thank you. So I work for Samsung SDS, which is short for Samsung Data Services. It's the IT company in Samsung Group. So you might know Samsung as a manufacturer of consumer electronics like phones and TVs. The group does much more than that, but most of the companies do produce some sort of physical device. SDS does not. We're the IT company in the group, so we run the data centers, we write some of the software, and we do some of the AI modeling. And my team is responsible for the artificial intelligence, where we have two major streams, and one does what we call AI engineering. That is, we create software for other people to make models with, and the other group is effectively a consulting organization that actually makes the models if our customers don't have the team or the expertise ready. So that's roughly what we do. In the product section, we have a product called Brightix AI Accelerator. It's there to accelerate your modeling efforts. So if you think that you have a data set ready and you want to make some AI model, the first question is, of course, what features of that data set are going to be relevant to your question. There's a feature engineering effort. This is typically 2 to 3 months of scientific labor on your human workforce to try to figure that out. There are many methods to do that. You can stock a small library of books and papers about this topic. We've automated that to a large degree. So you can dump your data set and have the computers churn out the best features for you. Second step, you need to pick the best model. Is it going to be an LSTM or a neural network or a support vector machine? Or how many layers is your neural network going to have and how many neurons per layer, et cetera, et cetera? All these model selection questions come up. Again, we've largely automated this so that you can dump the right features of your data set and have the computers figure that out. Third question, what are the right hyperparameters? Every algorithm comes with parameters of its own, the learning rate, the dropout rate, and things like that. There might be somewhere between 5 and 10 parameters that need to be tuned. And if you imagine searching for the right point in a 10-dimensional space takes some time. There are a couple sort of ways of doing that. One is manually thinking your way through it. That's the worst. Then there's a grid search by which you effectively divide the space into a chessboard and you try each square of the chessboard and hope for the best. That is better than manually doing it, but it's not very good. There's an adaptive search capability that we've built, not completely by ourselves. You can have it elsewhere as well, but adaptive search is the right way to do these things. It's much, much more efficient and leads you convergent to the right answer. Now, in order to automate many of these things, you need to do what's called distributed training. In other words, you need to distribute your training over several computers to reduce the amount of time. Anything that's automated means that the labor doesn't go away. The labor is just transferred from humans to computers. And so if the computers have a lot of labor to do, you either need to wait for a very, very long time, or you need to use several computers simultaneously to do that job. And that's what distributed training is all about. So we've implemented that. So that's our 4 major features that we have in this platform. Wrapped up together, basically they mean that you can go from data set to model with relatively little human effort. And in a relatively, defensible amount of time. It's still going to be macroscopic in the realm of weeks. So AI is not something that you do from one moment to the next.
Right.
But it is also not in the realm of years, what you might imagine.
Talk a little bit about the training of a model. with a data set. Can you give me some examples of what type of applications you are trying to train? And is this for an internal analysis, or is this for a consumer-facing application in the end?
Right, so we train all sorts of models. Some of them are for our internal use. An example would be scrap detection in our manufacturing facilities. So Samsung manufactures all of its own devices. We don't outsource that, so we own our own factories. So you might imagine that halfway along the manufacturing process, a particular part has broken for some reason or another. That's scrap. You want to detect that as early as you can and exit it from the process so that you don't add value to an item that's already broken.
Right.
So that's in fact our most valuable model in the semiconductor industry. Making semiconductor wafers that eventually turn out to be chips is a very expensive effort, and so isolating the wafers that got scratched or somehow damaged as early on as possible is hundreds of millions of dollars in cost savings kind of a model. At the other end of the pipeline, for example, you'll find things like Bixby. If you have a Samsung mobile phone, the application called Bixby is our verbal command and control module. You tell the phone what to do, like make a meeting or book a ticket, and it goes away and does that. Apple calls it Siri. That's, of course, a consumer-facing natural language processing AI model. So everything in between are models that we would make, right? Anything from computer vision over natural languages to time series, where we might do things like forecast how many people are going to purchase Samsung devices, at which stores are they going to purchase those, and on the back of that we then ship those goods from the manufacturer to those stores so that they're ready. Of course, the trick is to get the amounts right. We don't want the warehouse to be full of stuff that doesn't get bought, but on the other hand, we don't want to run out either. So that really then is the sweet spot right there.
Your background is in that type of process engineering. I understand from your biography that you have worked in chemical manufacturing processes, power generation, etc. Does AI give Samsung just that much more of a clear view of the supply chain and of sort of the manufacturing challenge as it gets ready to bring a product to market? Is that the main reason for the internal models?
So yes, my background is in the process industry. I did a lot of work for oil and gas and chemicals before I joined Samsung. And I would say yes, internally at Samsung, the primary benefit of these AI models is in fact in the manufacturing logistics area, simply because that is the bulk of what Samsung actually does. Samsung thinks of itself as a manufacturing company. And most of the company in terms of personnel and costs and so on is on the manufacturing logistics side of things. If you think about a physical device, there is some effort obviously expended in designing and engineering it, but far more financial effort and human effort is expended in actually building it at scale, right? So we make 1 billion phones. That takes more effort than designing it to some degree. Employing AI to assist with the manufacturing and logistics effort is certainly valuable. A lot of the high-tech, innovative designing of the next generation phone, we cannot do that with AI, right? AI is not actually intelligent. It's kind of a misnomer. Artificial intelligence is not intelligence. We mustn't confuse that, and Hollywood frequently does. So if we try to be innovative and design something better, something out of the realm of current technology, then humans have to do that.
Now, I go back to artificial intelligence to the early 80s when I was beginning as a tech reporter. And back then it was bandied about in terms of like decision support systems, things like handwriting recognition, optical character recognition, machine vision were established and making some headway, but uh, it seemed that the early efforts were, particularly on handwriting recognition or voice recognition, were very difficult to train. They required a lot of training on the part of the user. But now you skip forward 40 years or 35 years, and we seem to be having a renaissance in AI. What do you think is unleashing that? Is it processing power? Is it the cell phone? Is it the use of the cloud to provide this type of AI processing in the background? I'm very interested in what you feel is sort of kicking off this, what seems to me to be a renaissance.
Yeah, there certainly is a renaissance. It's sometimes called the deep learning revolution. So I think it's so some of it's down to processing speed. Yes, we now have these graphical processing units, the GPUs, that we didn't have 30 years ago, that make the processing a lot faster. And speed then therefore allows you to train larger models.
I see.
Right. So when we talk about making things faster, we actually have no interest in actually saving time. That's not interesting. Speed is interesting in the sense that it allows us, using the same amount of time, to train bigger models. That's where the benefit really comes in. And so the models relating to what you spoke about, like handwriting recognition or speech recognition, those models now are just a lot bigger. And therefore they become better at doing that. The second benefit is scientific. We've made some headway, and that's what the field called deep learning is all about, some headway since the 1980s in the mathematics of AI. We have novel algorithms, we have novel modeling methods available that are, in fact, a step change better than we had in the 80s. Those two are important. But the third is much, much more important. That's the real lever here, and that is the increased size of available data.
Because gathering more through sensors or through capture, why are the data sets increasing in size?
Well, yes, we're capturing more. We have also digitized more than was available before, right? So in the 1980s, human knowledge came in forms like books. Right now, these are available as digital books, right? So they can be processed, things like that. Data that used to be available as, paper photographs are now digital photographs. They can be processed. The equipment to record those things, like digital cameras or digital voice recorders, are now available that were not in the 1980s. And so we're starting to acquire data at a rate, digital data, right? Somewhat structured data, and structured in the sense of it's been digitized, it's recorded in files and stored. It is now available at a volume that is unique in history. And so that can be processed and learned from like never before. And that's really one of the major failings of AI in the early days, right? So when people went around and said, oh, the neural networks, they can solve every problem. The neural networks could have, but we didn't have the resources to train them on the computing side, and we didn't have the data to train them either, right? So you can imagine a human student, if you imagine a human 10-year-old who has to spend 12 hours a day in the cotton fields, and he's given 30 minutes a day to study, and during those 30 minutes the student is provided with no materials, no books or a teacher or anything. How much can that student truly accomplish, right? Now you put that student into an 8-hour a day school and provide good learning resources and a good teacher, that student can become a genius. that's the difference we're talking about with AI here. We have simply a different ecosystem.
Got it. What about the collection of user data? There's been a lot of noise on the regulatory and the legislative front to, lack of a better term, begin to vet or analyze algorithms in case they have any type of built-in bias or other inherent flaw. Are there examples of data capture on the part of users that we're not aware of? I mean, is it just simply as we drive our vehicles or we have an X-ray taken, does our data generally get pooled anonymously to drive these type of models, to teach them? Are we making the systems more useful the more we use them, I guess, is the question.
So by and large, yes, your data is being collected. So as you use social media platforms, as you drive your car, as you use your phone, that data by and large, yes, is being recorded in one form or another, and is then being used to make that product better. Better, obviously, from the side of its manufacturer. And in that sense, better, the first definition of better is always in the direction of monetization, right? So the manufacturer of the device or the maker of the software ultimately wants to earn money themselves, right? So that may not be congruent to your personal individual definition of the word better. It may not be better for you. So there's a conflict of interest here. And governments and regulators are trying to bridge that. And that's particularly relevant to people who don't belong to the normal majority, let's say. Right. There are various groups that will deviate from the normal majority, be it by skin color or by ethnicity or by heritage or by age, by health conditions, by disabilities, by the geography they live in, by the language they speak. There are all sorts of groups that will become or have already become marginalized in one way or another. So you can very easily imagine people who don't speak English obviously are much more limited in anything concerning computers or the internet than from people who do speak English, for obvious reasons. And you could make an argument for many other groups. So in the United States, we're particularly prone to speak about African Americans being biased against. That is one example, and it's certainly very relevant and important, but that is by no means the end of that discussion. And that's just bias against human groups. There are systems where bias is not the problem, but the entire use case could be construed to be a problem. So personally, I think, for example, having an autonomous drone outfitted with weapon systems and an AI that with the permission to fire whenever the AI thinks it's identified a target, that is morally objectionable and has nothing to do with bias against people, against groups of people. This is biased against humanity in general. So there are various issues of ethics and various issues of data privacy. So, for instance, the autonomous driving community is driving around neighborhoods anywhere in the world and recording visual data, street data, etc., which will obviously eventually record your house, right? Do you want to have your house being recorded in company X's autonomous driving software? And the scale between wanting that to objecting to it is, of course, a gray area. And European governments, for instance, have decided that you can object to it. And then the company will have to remove the images relating to your home from that database.
You know that. So just as the EU passed that right to be forgotten, that I can get myself removed from search results, I can also get my personal imagery taken down, or
Right.
or whatever. What is the compliance challenge like for a global company? In the United States, we don't have a national data privacy law like the GDPR. Most companies that operate internationally try to comply with every regime or body of law in the countries they operate. In this country alone, for a data breach notification, there are 50 different states with 50 different laws. Are we in danger of hampering the advance of AI through overregulation born from those Hollywood fears of Skynet or the drone that will have weapons and make a decision to shoot me?
Right. Yeah, it's a very important and complex debate. So first of all, the Skynet, completely unrealistic Hollywood fear-mongering. I personally believe that the sort of Skynet type machinery is not possible on fundamental grounds. But even if you believe that it could be made, we're certainly very, very, very far away from making that, right? So to your audience who might be afraid of the Terminator, this is not within our lifetime sort of a technology.
Right.
Now, over-regulating, there is a little bit of danger, of course, of regulating it to the point where the degrees of freedom are so diminished that the value is also diminished. Yes.
Right.
But I think the bigger danger is in the global complexity that you pointed out. Everybody has different regulations. In the US, there are 50 different regulations, and then we have the other regulations worldwide, and they're all different in some way, shape, or form.
Right.
So I believe that the best way to cope with it on a sort of global corporate side is to default to the strictest system.
Right.
What you don't want to do is separately comply with each legal code individually. That's a nightmare.
Right.
In that case, the cost of it is too high. And of course, these legal codes are not static. They evolve over time, right? So just studying up on what everybody is doing and what all their changes are is a nightmare for a company to keep up with. So just simply to default to the worst case, strictest code, which in the current scheme of things is the European code, that is economically the right thing to do.
Got it. Yeah, I agree. Can you talk a little bit about how you got interested in this field and what sparked your interest in it?
So when I was in school, I was always interested in how the world works. So that's why I took a physics degree at university. And I learned that physics is really a conversation between experiment and theory. And how it works is that experiment gathers data and theory tries to interpret that data, put it in context, come up with a model, which in physics always meant a formula, an equation, mathematical language model. I became a theorist. So I always saw that it took a very long time and somewhat uncoordinated genius spark moments to come up with these things. And so I figured, can't we use this newfangled computer technology that was emerging to help with that? And that's, of course, exactly what AI is. AI tries to fit a formula, a prototypical formula, right? The prototype of the formula is called neural network or support vector machine or random forest or something like that. That's a prototype formula. And then the algorithm fills out that formula by determining the numerical values of the parameters in the prototype. And so what I was wondering is, how do we systematize this art form that we call physics? And well, the answer to that really is artificial intelligence, because that takes the empirical data, creates the formula, proves to you that the formula is more or less sensible. And of course, since then, the world has been filled with computer-generated models that work really, really well. They don't explain, in quotes, the world as does physics, because AI always gets it wrong a few percentage points at a time. But if you can answer 98 or 99% of all cases with a formula that's been determined by computer, that's extremely fascinating just on its fundamental grounds, but it's also extremely practical and useful in everyday human life, right? As a practical person who tries to help other people, I'm not so much interested in the 1% case. I'm interested in the 99% case. And AI does that.
Artificial intelligence seems to be a term that's dogged the field for some time, going back to Alan Turing and the imitation game, or the Turing test. But going forward, well, let me take a step back on the question. What do you think is the most successful example of AI in practice? Would it be something like the Alexa? Was it the chat bot or the speech recognition of a Siri or a Google Assistant? It seems that we've made huge advances in the adoption of these technologies and these formulas without really being aware that it's AI. I mean, as one person said to me, autocomplete in a search box or in a word processor is AI, if you want to get down to it. What do you think has had the biggest impact in the adoption and acceptance?
Right. So there's a difference between general AI and narrow AI, right? And so narrow AI is all the models that do something extremely specific,
right?
Like recognize handwriting, do autocomplete when I type, recognize my face when I want to unlock my phone, recognize my fingerprint for the same reason to unlock the laptop. Pricing of airline tickets, suggesting what products I might be interested in purchasing on online shopping channels, things like that. Those are narrow AI. They've been deployed, they've been extremely successful, both for their makers in terms of economics, as well as for their users to make their life simpler.
Sure.
One AI technology I use several times a day is a GPS, right? You generally don't think of it that way, but the algorithm that tells me where to turn left and right, that's a form of AI also. So very, very useful. Now, none of those, please note, have anything to do with language.
Right.
Right. Now, let's go for the language side. The quality of chatbots today is not very good, to be kind. Completely useless might be a better description. Now, if you go to a website of very many manufacturers of goods like cars and otherwise, you will find that immediately a chatbot pops up at the bottom corner and offers help. If the audience here hasn't done that before, I challenge you, go to a website like that or a couple of them and try to ask some pointed questions, right?
Right. It's sort of like the old ELIZA program from the early 70s, where it just mimics, asks you, well, tell me how you feel about that.
Right. So those tools are extremely good at emotional answers, right? How are you doing today? Oh, the weather is great. The responses make a lot of sense. If you ask questions that involve either arithmetic or knowledge of the world, you will find their limitations immediately. Right? If you ask, for example, I have 3 pears and 4 apples, how many fruit do I have? You're unlikely to get the right answer. If you go to a manufacturer's webpage and you ask, factual questions about the products, you probably will not get an answer that makes any sense to you. That's the quality we're at. So passing the Turing test is one of those things. If all I do is small talk, then yes, the chatbots do quite well. But if I am inquisitive about, do you know the world? Do you understand basic facts like gravity and weight, relative size of things? Do you know that, for example, a cow, it cannot be 20 feet long, right? So if I give you a picture where there is the behind of a cow, a building, and then a head of a cow, the AI will conclude that you have a 20-foot cow.
Right.
A human will immediately say, well, there are two cows, obviously.
Right.
Yeah. So things like that, if I present the algorithm with examples like this, whether I do it verbally or visually, you immediately discover these limitations.
Right.
And fail the Turing test, right? So Turing himself did not give us a manual of how pointed to be with our questions during the half hour that he allowed us to have that conversation. But I think now we know we have to be a lot more pointed with those questions. And currently, we don't know of a good way to combine knowledge of the world with the very sophisticated natural language processing algorithms that we have, so that they learn from speech but don't really know things.
Right.
So another example is, I'm sorry?
NLP is just identifying audio signatures, right? It's looking at the waveform of the words I'm saying, and it compares it to a database and says, well, that sounds like he just said the word sounds like.
Exactly. And this is the other flaw of the system. It learns from the data it's being presented with. So for example, modern NLP systems are trained based on the writings on the internet. Now we of course know that a lot of writings on the internet are not true.
Right.
Many people write many things on the internet. And the NLP system will learn all of this. So it may suddenly have opinions that are just simply incorrect.
Right. I remember Microsoft released some sort of Twitter bot that just sort of deteriorated in its behavior the more it interacted with people.
Yes.
It's an example of garbage in, garbage out.
Exactly.
I'm conscious of time. We've run over. Is there anything you'd like to add?
So I have a little bit more time if you want to go on a bit longer.
Oh, that would be great. Yeah, I would love to. One area is sort of the automation of tasks, and an example. Well, let's take an example of that drone that is suddenly given the autonomy to make a decision. We don't trust it to do that. Ethically, we don't want, the device making a life and death decision. But if we go into, say, medicine, where AI shows a lot of promise in helping a physician or guiding a physician through a patient visit, as the physician is taking the notes and listening to the complaints, the system may say, have you thought about this? Or have you thought about that? In radiology in particular, it's been used, they've trained it by showing the system thousands of pulmonary embolisms and saying, now go identify pulmonary embolisms. There's still a factor where it gets it wrong, where it will either make a positive diagnosis or a negative diagnosis. It'll either miss the pulmonary embolism or it'll detect one that's not there. Is there a point where that error rate or that slight percentage of inaccuracy is going to become tolerable? Or are there applications where we just simply can't tolerate that, and there has to be a human check on the diagnosis or the output of the system?
Yeah, this is a very important question for many practical applications of AI, right? At which point of accuracy is it practicable to use this technology for real?
Right.
Now, there's a very interesting book by the title of Noise, published by Daniel Kahneman, the Nobel Prize winner of economics, where he goes into discussing that human systems are noisy.
Mm-hmm.
And we have a certain fault tolerance for that. And the fault tolerance that we have for computerized systems is on a completely different order of magnitude. And this is a very interesting societal development that I think is important to look at. So, for example, on average, not accusing any particular medical system of anything, but on average, doctors get the diagnosis right 70% of the time, which means 30% of the time, almost 1/3 of the time, they are not correct about the diagnosis. Computerized systems, especially if they specialize in one particular disease, are typically 98, 99% accurate. So only get it wrong 1 to 2% of the time. So the requirement to say we need a human check in addition to that is actually getting a better system checked by a worse system.
Right.
Is that an improvement? Right? So purely statistically speaking, that may not be a good idea.
Right.
Now, in terms of generating trust on part of the patient involved, right? In a particular individual case, of course, you've got a real life human being sitting there being worried about their health. Then it makes, of course, a lot of sense for the human to look at it and for the human doctor to agree and to explain to that patient what that diagnosis means. But nonetheless, the likelihood of being right is a lot better with the computer than with the human.
Right.
Now, the human, of course, can do things that at the moment the computer cannot do at all. For example, explain why. Right? If you come into the doctor's office and the computer tells you, you've got cancer, period.
Thanks.
That's not very helpful, right? Now, what the human doctor would be able to do is to say, you've got cancer, and here's the reasons why, and now here's the stuff you need to go do about that. Right? And at the moment, computer health systems are not capable of doing that. They're not capable of, first of all, explaining why the diagnosis is what it is, and they're also not capable of explaining what you can do about it.
Right.
So it necessarily needs to be a computer-human hybrid interaction that actually gets the problem solved. And I think this is where the real secret lies. Doctors and patients need to become familiar and comfortable with the fact that AI systems are now a helpful tool around the doctor's office in just the same way that a stethoscope and a scalpel or a microscope are useful tools around the doctor's office. They do not substitute the doctor. They help the doctor in getting the job done.
That's about it for the top questions. Anything that you'd like to add that I haven't asked?
No, I think this was a very good conversation.
Well, thank you for taking the time. I really enjoyed it. You're obviously very smart at this topic, and it's been a real pleasure to meet you and learn from you. Thank you.
Same here. You asked some very insightful questions. Thank you. You obviously